So question 5 says, use the rational roots theorem to list the potential rational roots of the polynomial function. Do not attempt to find the actual zeros. So we just have to find potential rational zeros. So remember, rational zeros can be fractions, decimals, integers. It's kind of what we're talking about. So what is the rational root theorem? So again, we have this gentleman, his name is Rene Descartes. He's a very famous mathematician. So again, if you want to look at some of his some of the things he's brought to the math community, it'd be interesting to kind of do a little research on him. So he discovered that the potential rational zeros can be found by using this ratio P over Q, where P is the possible factors of the constant and Q is the possible factors of the leading coefficient. So if I look at our problem here, the constant is the -5. So the factors of a -5, if I make my little t-chart, notice that 1 times 5 is the only way to get a 5 since 5 is a prime number. Now, to get a -5, the 1 could be positive, the 5 could have been negative, or the 1 could have been negative and the 5 could have been positive. So what we pick up on is when I list the factors of a -5, they actually become this plus or minus 1 and this plus or minus 5. We have to include both signs. So those are going to be your P's, the plus or minus 1 and the plus or minus 5. The Q's are going to be the factors of the leading coefficient. Well, x to the 5th is the leading term, so 1 is the leading coefficient. So the factors of 1, again, notice that 1 is a prime. Actually, 1 has just one factor in itself. So we could be 1 times 1, or we could have had a -1 times a -1. So what we do here is we use plus or minus 1 as our possible factors of 1. So again, P over Q becomes our potential rational zeros, if you will. And so what we did is we put 1, since P could be 1 and Q could be 1, I could write this as plus or minus 1 over plus or minus 1. You also have P could be 5 and Q could be 1. So you could also have plus or minus 5 over plus or minus 1. So those would be the different ways to write that. If we simplify those down, 1 over 1 is the same thing as 1. So plus or minus 1, and 5 over 5 is just 5. So plus or minus 5. So that would be our different potential rational zeros, would be those. So if we look up here, we're seeing that C looks like the thing that matches our so positive -1 and a positive -5 would be our potential rational zeros. Now, if I want to go ahead and work this out, take a little bit further, we don't have to do this, but if we do, we can go y equals and type in this x to the 5th. And then we have minus then this 2x squared plus 20x minus 5. Now, if I go to my table, using the remainder theorem, we could look at this, going the other direction, sorry, wrong way. So if we look at f of 1, notice that the remainder is 14. So that is not a 0. If I look at f of -1, notice that my remainder is a -28. So that is not a 0. If I look at f of 5, notice that we get 3,170. That's not going to be a 0. If you look at f of -5, oops, come back over, and we get -3,280. So notice that those were the potential rational zeros, but none of them actually even worked. So this becomes a much more complicated problem because of that. So let's see if I actually put it in correctly again. X to the 5th minus 2x squared plus 20x minus 5. Okay, so I did, and if we look at the table again, we did not see any of those actually even being zeros. So we have a lot more thinking to do on that problem to solve it.